rational exponent 6.4 really is about rewriting and then simplifying from exponential form to radical form and radical form to exponential form, and really using whichever form helps us simplify or solve an equation or an expression here. So we've got this key concept here that says if the nth root of a is a real number, m is an integer, and m over n is in its lowest terms, then we have a to the 1 over n power equals the nth root of a. So this is important to note. If you don't see an exponent underneath the radical, then that means that there's the numerator is equal to 1. If we have a to the m over n, so we actually have a number that's not 1 on the top, then that value gets put as an exponent underneath the radical, and it can be written either way here. So this is really important to note the two different ways that we can write this. So if I'm asking you to simplify an expression, and I don't have a calculator in front of me, but I have that cheat sheet that we did back in 6.1, 6.2, I could rewrite this. This says 1 over 3. So how I would rewrite this is the cube root. So I have an index of 3 of 216, and this is a perfect cube where we have 6 times 6 times 6 equals 216, so this would equal 6. So I have the same thing here where I could rewrite this as the square root of 7 times the square root of 7. Notice I don't put an index of 2 here. That's because if we have an index of 2, it's called a square root. We don't have to put it. Cube root, I have to put the index. So this would be the square root of 49, which is nothing more than 7. Okay, so again, we're going to do a lot of rewriting in this section, and it really stems from this right here. A to the m over n is equal to the nth root. I always say the denominator goes in the index goes in the denominator, and we're just going to use whatever method helps us solve this. So again, if I were to write this out, I've got the 4th root of 5 times the 4th root of 125. Denominator's my index, the numerator's my exponent, but I don't have to put 5 to the first power. Well, now that I have the same index, I can multiply these two numbers and I get the 4th power of 625, which reduces to or simplifies to 5. Okay, so again, the key concept is written here. Just want to make sure that I stress that. We're doing a lot of rewriting. Okay, so 2 examples here. What are x to the 3 over 7 and y to the negative 3.5 in radical form? So x to the 3 over 7th power would be the 7th root of x to the 3rd. There's nothing else you can do with this. You can't simplify that. Now, for this next example, I've got y to the negative 3.5, which could be written as y to the negative 7 over 2 power. Well, now I've got some work to do here, okay, because this negative tells me to put it as y to the 7 over 2nd power, which would be 1 over the square root of y to the 7th power. Now, if you can simplify this, I need to simplify it. Are there groups of 2, right? My index is 2 that I could take out from 7y's, and the answer to that is yes. So I need to take out, again, y to the 7th means 7y's, right? How many groups of 2 can I make? 1, 2, 3. So this simplifies to y, 1 over y to the 3rd square root of y. Well, here's the problem. I'm not allowed to have a radical underneath the denominator. So I need to rationalize the denominator by multiplying top and bottom by the square root of y. So on the top, I get square root of y. On the bottom, square root of y times the square root of y is equal to just y. So I have y to the 3rd times y to the 4th, y to the 1st, which is y to the 4th. So that little problem, y to the negative 3 over 5th, technically simplifies to the square root of y to the 4th, just going through all my exponent rules. But the first thing that I had to do was rewrite this as a radical. So we got to be able to convert back and forth, and all those rules that we heard are the truth. So now we got to be able to go from radical form to exponential. What's the index here? Index is 2. So I have a to the 5 over second power. That's it. All I'm asking you to do is rewrite it. Okay. This one here would be b to the index always goes on the bottom. Index goes on the bottom, so it'd be 3 over 5. Nothing more to that. So being able to rewrite these is key for these problems. Now, this is where it really comes into play here. So it says, what is, now I don't have the same index here, so I can't divide. But if I rewrite this as x to the 3/4 divided by x to the 2 over 8, well, if I have the same base, all I do is subtract the exponents. So I could rewrite this as x to the 3 over 4 minus 2 over 8. And hopefully you're good with fractions, or you have a calculator. 3 over 4 minus 2 over 8 is the same thing as 6 minus 8. This would be x equals 6 over 8 minus 2 over 8 is 4 over 8, which is x to the 1/2, which is the same exact thing as the square root of x. So that would be the simplest form, by writing them as exponents. And then using my exponent rules, same base, I subtract the exponents to simplify this. And again, either one of these answers is correct, but most of the time when I'm given an answer in radical form and ask you to write it in simplest form, I want the answer in radical form. Okay, so this problem here, what are our exponent rules? Well, the first thing that I need to do is distribute. That goes to this, that goes to this, that goes to this. Okay, so I've got -8 to the 2/3 power. I've got x to the 2/3 power, and I have the square root of xy all raised to the 2/3 power. Well, again, what does that mean? I can rewrite this. This is the cube root of -8, right, squared. This is the cube root of x squared. So that took care of this and this term. This term right here, well, what does the square root of xy mean? It means x to the 1/2, y to the 1/2, and all that's being raised to the 2/3. So this right here, the cube root of -8 is -2. So I've got -2 squared. Can't do anything with this. This stays the cube root of x squared. This would be x to the, multiply those, x to the 2 over 6 power. And this would be y to the 2 over 6th power. Can you simplify anything here? Yes. What's -2 squared? 4. Again, I've got these written as exponents. So watch what I do here. I'm going to rewrite this as x to the 2/3, x to the, reduce this, 1/3, and y to the 1/3. So when I simplify this, this -8 to the 2/3 became a +4. Okay, x to the 2/3, x to the 1/3. I add them, gives me a 3 over 3, which is just x. And then y to the 1/3 is the cube root of y. And again, I simplified this and left it as a radical because it was given to us as a radical. You could also write it as y to the 1/3, get the same exact answer. Okay, so here be 16 to the -3 over 4 power, and y to the +24 over 4 power. All I'm doing is multiplying these two fractions. That's my exponent rules back from pre-algebra, algebra 1. So how does this get written? This is the 4th root of 16, all raised to the, what power? All raised to the 3rd power, but it's all over 1. Why did I put that over 1? Because I have a negative exponents. Negative exponents gets flipped. Okay, times y to the 6th power. So now the 4th root of 16 is 2. 2 cubed is 8. So I'm left with y to the 6th over 8. Okay. So that's 6.4. Again, it's just a lot of rewriting and looking at these exponents. Really need to know this right here, and know that when you're going from one form to the other, the index is always in the bottom of the exponent, and the exponent is always in the numerator of the given exponent.